To draw the graph of y equals x cubed, where x is a value between -2 and 2, we draw up a table of values. The values of x are -2, -1, 0, 1, and 2, and then we substitute each of these x values into the function to find the corresponding y value. So -2 cubed will give us -8 for y, -1 cubed will give us -1 for y, 0 cubed will give us 0 for y, 1 cubed is 1, 2 cubed is 8. We then plot these points and draw a smooth curve through them, which is here. Call that A. Then it was -1, -1 over there. That's B. 0, 0, C. 1, 1, that's D. And then 2, 8 is here. That's E. Now we're just going to draw a smooth curve through these points. So the function looks like something like this. Complete the table to draw the graph of y equals 0.5 times x to 3. Okay, we're not going to look at that. Y equals a half x cubed is so much easier to work with. In decimals here, so we are going to approximate -7.8. As much as it grinds me to use decimals, I'm reluctantly going to be doing that to complete these values. So this is the function y equals a half x cubed. Use your graph to solve the equation a half x cubed equals 6. So they want us to solve this equation here. So what this means, this half x cubed is really y. So they're asking you find the value of x when y equals 6. So when y equals 6, we make a mark on the y-axis, we move across to the function, and then we drop a perpendicular down and get as accurate a value of x as we possibly can. We can't see it on this grid because the divisions aren't small enough. The x value, if you want to know, x cubed will equal 12. So x is approximately 2.28, so it's approximately 2.3. Question 3. Again, we're going to take each x value that's been given to us, substitute it into the function y equals x cubed plus 3, find the corresponding y coordinate, plot the points, and draw a smooth curve through them. The function that's been sketched is y equals x cubed plus 3. They want us to solve x cubed plus 3 equals 0. Because x cubed plus 3 is y, essentially y equals 0. They want us to find x when y is 0. Y equals 0 at the origin. We move across. Because you're trying to find x, we have to move horizontally. So we move across until we get to this point here. Call that point A. And we read off that value. That looks to be -1.5 or -3/2. Now, the value algebraically, x cubed equals -3, so x is the cube root of -3, so x is approximately -1.44. -3/2 is -1.5. So again, if your block paper has divisions small enough, you can read off a much more accurate answer. Question 4, again, take all the x values in the table, substitute them each into the function y equals x cubed minus 2x plus 5. Find the corresponding y values, plot those points, and draw a graph. Use your graph to solve the equation x cubed minus 2x plus 5 equals 3. Okay, so they want us to solve x cubed minus 2x plus 5 equals 3. X cubed minus 2x plus 5 represents y. So essentially they're asking us find the value of x when y is 3. So we find y equals 3, which is there. We move horizontally across to the function. We get to this point here. We'll call that A. Drop a perpendicular down to your x-axis and read off the value. Again, not visible from this particular grid because the divisions are not small enough. But if your grid, your block paper, your graph paper is accurate enough, you can read the value of the graph. Use your graph to find the root of the equation x cubed minus 2x minus 2 equals 0. Okay. They want us to solve this equation over here. Now, we know what roots are. Roots are the x values to an equation, the solution to an equation. So if we take this equation here and we add 5 to both sides, we're adding 5 because we want this expression. We want that because this is our graph, right? That's what we've sketched. But they want x cubed minus 2x minus 2 equal to 0. So we're taking x cubed minus 2x minus 2 and we're adding 5 to both sides. The reason we do that is because we want this expression. We want this expression because this represents y, and that's the function that we have. We get this expression from here if we take the minus 2 across there. So that will equal 7. So essentially they're saying find x where y equals 7. So where y equals 7 is over here. We move across to the function and then drop a perpendicular down, and we're going to read that x value off. Question 5, again, we have a table of values here. We can substitute every x value into the function, find the corresponding y value, and then plot all of those points and draw a smooth curve through them. So this function is y equals x cubed minus x squared minus 6x. They want us to solve the equation x cubed minus x squared minus 6x plus 5 equals 0. The first three terms here represent y, so essentially y plus 5 equals 0, y equals minus 5. They want us to find x when y is minus 5. So we go to minus 5, move across to the function, and then use your ruler, drop a perpendicular up to the x-axis and read off that value of x. Use your graph to find the coordinates of the turning points of the graph. Okay, so the turning points of the graph will be at this point here and at that point there. And depending on how accurately you've drawn this graph and how many divisions you have on your grid paper, you just drop perpendiculars to the x-axis to read off the x value. You then move horizontally with your ruler for that point to the y-axis. You read off that value. This is the point P, x, y, whatever the value is, slightly less than 2 and just slightly less than minus 8. And this one Q, you do the same thing. You drop a perpendicular down to the x-axis, read off the x value, horizontally across to the y-axis, read off the y value, and this will be the point x2, y2, p is x1, y1. Whatever those x values are, depending on how you accurately have drawn your function, you then just read those values of the coordinates of the turning points of your graph.